So I think we are live now.
Yeah.
So we'll wait for a few minutes so that people can join in, and then we'll start.
Yep.
We'll give a minute or two so that everybody joins in, and then we'll talk about this topic.
Right.
PC people joining in. Okay, I think people have joined in and we can start. Welcome everyone for today's session on AI-assisted test automation with GitHub Copilot and Claude Code. Myself, Alias Gachaiwa, I am CTO at Tested Technologies, and today we are here to discuss, share our ideas and approach how we have used this AI-assisted test automation in multiple of our projects with customers, and we'll talk about how Playwright and MCP works, and we'll demonstrate a few examples and how we can implement this practices for the test automation. Just a moment. I think the slide is stuck. Okay. You can see my screen, right? Okay.
Yeah, it's visible.
Okay. So there's a slowness over here. It's okay. So we are an independent software testing company. We are AI native QA engineering company. We have been in industry for last 10 years and working on software testing. We do support 80 plus customer across different geographical location, and we are enhancing our automation with AI agents and using LLMs. How we can provide better solution to our customer with AI into place with test automation. Uh, So today with me, I have Abhishek and Rajat, who is going to demonstrate how they have implemented the AI agents in test automation framework and what are the benefit that they've seen while working on the customer projects. Now, why we chose this topic? So I think everybody's talking about AI agents, LLM, MCP. So we want to talk about why and how we should use these AI agents for test automation. So as we have seen that modern apps that are built with better technologies now, that releases are faster. So there is a need of test automation to be also faster, because most of time we have seen the customer that the testing becomes bottleneck for the releases. So we want to talk how we can fast track that test automation with AI into place. Also, now AI assistants, the AI agents, along with the test automation, can build tests faster, better. They can explore the application, they can build the test, they can write the script. So that those kind of heavy lifting is done by AI agent, and QA can focus on the business scenarios, what has to be covered, and those activities. Now we have seen recently with Playwright, which is has been a very advanced tool for test automation. Along with that, they have recently launched MCP. So we have been using MCP a lot with for our applications. So MCP provides real insight to the agent to explore the application and build test around those applications. It gives a complete accessibility tree to the agent so that it can explore the application and build tests around it. So that is why we are talking about this topic, because we want to make sure we are using AI in automation and fast tracking the whole process of quality engineering. Now, for today's agenda, we will understand what is the current approach, because everybody is using Playwright, everybody started using MCP, teams are using AI agents. Then we'll talk what is how we used AI assisted agent in our test automation and how it has helped us. We also cover a real use case. So this real use case is more about our own test rig community platform that we have built, and how we have used the AI assisted agent and automation to fast track the automation and have implement the best practices for test automation. Then that will be followed by a live demo where we'll cover both Copilot and Claude Code, how we have integrated with Playwright MCP, and what is our approach that we use for automation. Then we'll have a Q&A session. Then I think feel free to post your questions on the comment section so that we can take up those questions either in between or at the end of these sessions as we are going through this topic. Now, as I mentioned that, Playwright came up with MCP, and teams started using MCP agents. It has really fast tracked the whole automation process. You just need to provide few instructions, few setup, and it will explore the application. It will build the test, and it will make sure that all these practices are there right now while building those tests. Now we have to be very specific when we are using Playwright MCP and provide instruction to the agent. Write a particular scenario, build particular spec file, and those instructions has to be provided. Now, as teams start using different models, some of teams start using Copilot, some are using Claude Code, some are using Codex. These standards vary for the framework depending on the understanding of the model, and each model will have a different standard when they build. And we've tried with different models with Playwright MCP, and we've seen that each model has its own understanding, reasoning while building the framework. Now, with Playwright, as I mentioned, it provides the generator and healer. So the healer is more often goes and try to fix the test that it has built. So it does multiple retries and fix it. So this is a standard approach. Everybody is following it right now, and it is really adding value to the team. How they can write tests, how we can automate. Now I'll talk about what is our approach, how we have implemented Playwright MCP along with this AI assisted agent, to generate the test cases. Now, when I mention generate automation test cases, we already have built a utility in-house where we are, with AI agents, we are writing test cases, providing the Jira ticket information, integration with Jira ticket, integration with Notion, integration with Linear. It supports multiple integration, and it can explore the application, build the maps, and it will also generate test cases. So we'll have a demo session sometime next month. We'll talk about how we have built this utility so that we can share you how it has helped our team to fast track the creation of test cases. It can build BDD format test cases, can build standard format of test cases for web application, for API application. We'll cover those areas when we demonstrate these utilities in next sessions. Then these agents that we're talking about, these agents had pretty clear understanding. It has been fine-tuned. It has all the guardrails defined that what the agent has to perform, what it has not to perform. For example, what kind of locator strategies it has to follow, what kind of structure of the script it has to write. So those things have been provided as instruction to the agent. And the advantage with that, it reduces the maintenance of the script. It is kind of Everybody, when multiple team members start using this framework, they will come up with same standard because the agent's following the same standard. uh, Along with that, we have fine-tuned this agent to pinpoint the root cause while it is building the test or while it is running the test, and it applies the fixes while it is checking, exploring the application. We also, as I mentioned, we also use a lot of Playwright MCP capabilities so that while building the test script, the agent is exploring the application and understanding the locators, understanding the DOM element, and then building the script. And then it is also making sure that it is following any update that have been done on the application and modifying the test. So that is our approach. We'll have definitely demonstrate how we have done it. So as I mentioned, we will talk about a real use case where we have our own testing community platform that we have built. That platform provides opportunity to QAs to come and read about new trends in testing, area, publish blogs. So that is a platform that we have built for testing community. Now, while building that community, we wanted to make sure that we have automated test pipeline in place, and that is where we started using this AI assisted agents to write test case, to validate the scenarios, and make sure the regressions are updated, because there were multiple builds happening while we're building this platform. So our requirement was very clear that we want to have automated workflow. We wanted to make sure the user journeys are working correctly, and we want to make sure that it has regression test available every time when there were check-ins are happening, to make sure those things are not broken. And there were challenges because this is a JavaScript framework. We had models, we had pop-ups, and we had a lot of failures. So we want to trace those things while we want to build automation. So our solution was to have AI assistant agent that works with Playwright, and the Playwright boilerplate was provided to the agent. The agent had predefined instructions, so it has to follow those instructions. Do not drift from the instruction, and make sure that it is not consuming a lot of tokens while it is building the test, or it is not writing scenarios which are not really valid for the application. And then these were the guardrails, and the fine tuning of the agent was done, because we have done build a lot of automation framework for multiple customers. So we wanted to build our own custom agent which has all those restrictions in place for the agent to follow. And then again, with these AI agents, we diagnose these failures, we analyze those failures, we fix them, and then the agent was taking care of applying. But then there was always human in the loop who is verifying these changes and applying those to the framework. So I think now we will talk about live demo where we will cover Playwright MCP. Along with that, we'll cover both how we have used it with GitHub Copilot, and along with that, we'll also showcase how we can use Claude Code with Playwright MCP. So I think now I will ask Abhishek Jadhav to share the screen, walk us through the demo, tell us how it was implemented, and what are the benefit of using this custom agent while building this automation approach. Over to you, Abhishek.
Yeah, thank you, Ali. So in today's demonstration, we will be covering how we can utilize the Copilot agents to fast track the automation process. So for that, first of all, I'll walk you through our boilerplate that we have designed to work with the Copilot agents. So this is the first GitHub folder. In that, we have the instructions folder where we have written the POM instructions. So while writing the page objects, AI needs the context, like what the structure needs to be followed and what are the rules that needs to be followed while doing the coding part. So these instructions has been written in this file. So after that, we have this prompts folder. So in that, we have this custom agents built. So basically, we have two agents here. So first of all, first one is heal agent. So what it does, like if there are any spec file fails, so we can just have to give the /heal command. So that particular agent will check which particular spec files are failing, use the Playwright MCP and accordingly fix those. Same, we have the scaffold agent. So the scaffold agent has two parts here. So it does the planning part as well as the execution part. So we'll go through it by them by actual demonstration. So next we have this agents.md and copilot instructions.md. So these two files are like a source of truth for the AI agents. So whenever we give any task to them, they should follow these instructions and execute the tasks accordingly. Further, we have the fixtures folder. In that, we have the template folder. That particular we have for the context for the AI. So whenever we give any instructions to the AI needs to have the context, what needs to be written for the particular task. So this particular example fixtures.ts helps AI to write the fixture files, and accordingly we have those instructions in other folders as well. So this is the service UI folder. In that we have example page.ts that guides AI how to write the page objects. And then further in the test folder, we have the example spec file. So example spec file is like how test spec files should be written. So accordingly it will be executed. Yeah. So the requirements folder that we have.
Abhishek, just I think you can reshare your screen because it seems the screen is still blurred. But I think what I want to add over here, like we have defined these agent instructions, the boilerplate, the fixtures, so that while using these agents, it is actually understanding what is my structure I have to follow while building the test. What are my predefined validations that I have to follow. Even the examples, how the structure of the test should be, how the locator should be defined. Those things are defined in the these prompts, and that's what it helps agent while it is writing the test. It's not kind of writing the test where we need to rework and fix it. So it's always making sure the standards are followed. I think Abhishek
Yeah.
still we see a little blurredness on the screen, but I think carry on.
Yeah. So this is the first of all, the login MD. So in that we are following the Gherkin scenario here, where we have implemented the 5 scenarios that we are going to follow to execute the automation script. So while doing this thing, so we just need to give this file with slash scaffold command. So in this scenario, that particular agent will understand those scenarios, use the Playwright MCP, and understand the work tree as per the scenarios and get the locators for us. So if you see here, like it will be like navigating through the files and also the folder structure. So whatever the folder structure currently we are following, it's gone through the all files and understanding what we currently have and what needs to be done. So that particular example files that we have implemented, that helps as a context. So it's gonna follow those things. So currently it's using the Playwright MCP. So it will navigate through the 5 scenarios that we have implemented in the login file. So while doing this thing, so this makes sure that AI will not make the locators and you validate actual through the real application. So that gives us advantage over looking into the random locators or like AI creating the locators. So this accessibility tree gives us advantage, like if there are any new changes in the application, that also can be addressed with the help of this. Yeah. So it's going to follow the scenarios that we have implemented and go through the work tree, understand those scenarios and give us the plan. So with this thing, we are making sure like the scenarios that we have given are in the Gherkin format. So AI exactly knows what needs to be performed and what output needs to be given for the writing the assertions or in the spec file.
So
So
Abhishek, one thing
AI
over
can
here,
make
I think
mistakes, but with our custom agents, we have add-on.
one thing over here, like because you have defined the scope for agent, so it has very clear understanding what test write, what test data it has to use. I think that gives very clear instruction to the agents.
Yeah, so that clear instruction needs to be given because whenever we give any task to the AI, the context is the key for the AI to deliver the better quality output. So these instructions help them to write the better output for any scenarios that we have given. So it will write the proper page objects and spec files, and but we particularly don't need to like give manual instructions again and again with this type of like predefined rules. Yeah. So here we can see that it has given the plan that needs to be executed when writing the page objects and scripts. So here it has given the accessibility tree and what are the steps it has performed and what is the actions that agent will perform to execute the task and deliver the output. So once we can review this plan and once we give access to like it, uh, green signal to the AI, so it will turn into the execution mode. Use that particular plan, the locators that it has identified, the accessibility tree that it understood, so that can be used to write the page objects and do the any required things. So that accordingly implemented and it's gonna execute them and verify the results as well. So we'll check one by one. So first of all, it's understanding the accessibility tree and checking what needs to be edited in the folder structure. So it has checked we previously don't have any page objects and the spec files. So it has clear now instructions like it needs to be created newly files. So that gives us advantage. Whenever it checks the folder structure, it will not create the duplicate spec file or the page object. That is like a better understanding for the AI. So it will not give the duplicate work and not waste the tokens there. So here we can see that it has created the page object file. So here we are prioritizing the playwright based locators first, so that can avoid the flakiness and with the current development with the AI thing. So when we use the normal locators like CSS selector and XPath, that make break with the AI changes. So this playwright based locators give us advantage, avoids the flakiness and better durability for execution of the automation test suits. Yeah. So in first go, we cannot like make sure that AI will accurately give the results. So with the Copilot, we have advantage that we can use the different models. So currently we are using GPT 5.3 codex. So that is particularly designed for the codex. So it understand what needs to be performed for the coding part. So if we choose the different models here, so that gives us different advantage because each model has their own reasoning. So in some of the models that we can see, it can complete the work within the one go, and some of them can make mistakes and make correcting them. Yeah. So after writing the spec files and the uh, page objects, so it's gonna run the quality gate. So this is the particular quality gate that we have given in the rules that needs to be performed whenever we are executing the scripts. So the lint check, type check, and the formatting needs to be performed where whenever your AI updates any line of code in any file. So that gives us advantage like what we expect from the particular QA engineer, that quality of the code should be maintained, the framework should be maintainable and scalable. So this kind of things we are addressing through the proper instruction.
So, Abhishek, one thing over here, like we have implemented link check, so
So
it will follow across. Even if other team members are using same framework, they will always make sure the code that is being generated is following these type checks and format checks and link checks, right? Whenever it is been created by the agents on their own machine.
yeah. So this is the particular boilerplate whenever we can, this is the generic boilerplate that we have designed. So in any application, when we give this boilerplate to a particular QA, when they use this Copilot thing, they can, these instructions will be followed automatically because we have these files and instructions already written in the boilerplate. So whenever they want to automate something, when they give task to AI, AI will automatically adapt them and execute those things. And further, this particular framework can be fine-tuned for the particular application. So in some of the scenarios, like we can take example of our test community for according to the tech stack and application understanding, we can fine-tune the agents so they will perform much better for that application specific scenarios. So in this quality gate, it has found the lint errors and it has fixed them. So these kind of fixes are required when we want to maintain the quality of the framework and make them executable. So after that thing, it will execute the script spec files that it has written. So we have 5 scenarios written into the login.md. So it has created those in the spec file and it's going to execute them. So here we can see that we have implemented logging also. So this logging helps AI to understand the failure things. So we can take example whenever like some of the spec file fails, AI first understand them through the terminal. When they extract the terminal output, they, with the help of logging, we are giving them proper context at which step particular spec file is failed. So they can understand those things, go to that particular spec file, understand that particular step and fix those accordingly. So here we can see that out of 5, one of the spec file is failed. So it's gonna understand this thing, like why this particular scenario is failed and fix them accordingly. So it has identified now, like from the terminal, that particular scenario in the forgot password, it has the incorrect message. So it has made the fix for that. So previously the message was the incorrect invalid username, so the incorrect password text was missing from the assertion. So it has added back and it will now execute the tests again. So now it's like all tests now passed and currently it's gonna check the setup thing. So this particular setup command, it has created by its own to maintain the storage state. So whenever we are executing any scenarios, we should not be doing login again and again. So it is maintaining the storage state for that. So now we can check regarding to the real world scenario, like whenever like the application is in the development process and it is like uh, in the particular phase where the features are upcoming changes, breaking the automation test suits. So here we can like just execute those scenarios in such a way like we can like just try to break a locator that can uh, fail the script. So accordingly, so it can demonstrate the real world scenario, like if whenever developer push new changes, that scenario can break the automation test suite. So where we can, how we can use our heal agent. So that particular heal agent gonna execute the particular spec files, understand those failures and accordingly fix them. So here we have updated the locator with adding some text and removing some of the characters. So here we just have to give the /heal command. So in this particular thing, we have implemented in such a way, like we tried with our multiple real applications where we have another clients and where we found that like with traditional thing, the particular agent can run into the loop, waste the tokens and like just trying to fix those problems that are not fixable. So with that kind of scenario, we have updated it in a such a way, if that particular problem is not fixable, it's gonna return back to the QA and report him that this is the not fixable. So you can like report this as a bug, so it will not waste tokens. It will check through the actual accessibility tree. So here we can see that it has found that particular forgot password scenario has the mistake. Because of the previous context in the session, it has made that thing. But in future, suppose we don't have that particular in the session memory. So what it can do, so it has given the instruction to use the Playwright MCP. So for that particular scenario, the spec files that are failing, it's gonna use the Playwright MCP, go through the real application, find out what are the changes. If those are fixable, it's gonna update the spec file, fix those changes, and accordingly report. If that is not fixable, then it will report back to the QA, so we can file that as a bug. So that can also address. And with this thing, we can make sure that QA can focus on the actual critical business scenarios, and this part can be performed by the AI. The repetition part, like writing the page objects, finding the locators, or writing the spec files, can be performed by the AI to give the better productivity work and deliver the best results. So this
So I
is the
think just
overall.
just to summarize, so we have provided a boilerplate, with our best practices. We created a boilerplate for Playwright, and then along with that, we want to use Playwright MCP capability, but with the defined custom instruction to the agent. So, Abhishek, you have tried this with, without a custom agent where you use with Playwright MCP as a agent, and you used it, and now you have used with a custom agent. So, what are the benefit that you have seen when you implemented this approach?
So basically, we tried both the Playwright default agents plus our custom agents. So when we tried the Playwright default agents, we found that there are some limitations. Like when you go give the task to the planner or some other agents, we need to give the manual instructions to prompt them to understand what are the requirements and then execute them accordingly. So in one go, we cannot make sure that it will deliver the better quality output and waste the tokens. But with our approach, what we found that if we give the proper scenarios to the AI, like what needs to be performed from the requirements that we have, so it's gonna deliver the better quality output. So there are some pros and cons. Like Playwright agents are like more suitable when we are using the some of the scenarios that needs to be automated with some kind of things like there are Playwright MCP required. So in this scenario, when we use the Playwright default agents, we found that there are some like try fix me scenarios in the default agents that we utilized in our custom agents also. So whenever there are some of the scenarios that are not fixable, so it will mark that particular scenarios as a fix me tag. So that particular tag helps the QA to identify those scenarios, check what are the issues in there so they can fix them manually, and check with AI again so that scenarios can be automated further.
I think thank you, Abhishek. It was a great, demo that you covered how you use Copilot. I think now moving it, we'll talk about how we have used Claude Code, because most of the teams are using Copilot or Claude Code for the development and testing activities. I think I will ask Rajat to walk us through how we have implemented this custom agent approach with Playwright MCP and Claude Code as an AI-assisted agent to write test, run test and verify the scenarios. Over to you, Rajat. I think you can share your screen and walk us through how it's been done with Cloud Code.
Okay, thanks, Ali. So, thank you, Vishek, also. So now we will discuss the same approach with Claude actually. So we have used the same application for the demo, and in difference of the Copilot, here we have Claude.md. So here we can see that it is the heart of this application. So this is the first file that Claude reads. So here it consists of a project engineering handbook, and we have here some automation framework standards, coding conventions, naming conventions, coding expectations, and project architecture. So instead of giving all these again and again, we have stored into the Claude.md, and that is received by the Claude automatically. Then comes the .claude directory. So the Claude directory extends this concept, right? So here we organize commands, hooks, and skills. So better than storing the project code here, we store the project intelligence. So first, there is commands, skills, hooks. So what is commands? With the one of the few questions which we often receive is that the commands. Think of commands as a reusable automation workflows, right? So for example, instead of writing, read my requirements, create page objects, create services, create test, heal test, create some or anything from the weak prompt and everything every single time. So we simply execute one of the commands that we have written. So for example, scaffold, heal, create object, and everything. So that command needs that commands knows what to do and what not to do. So these commands reduce the prompting effort while ensuring that every framework is following the same standard process. So we have made some custom commands that is the create page object, heal, MCP debug, scaffold, and everything. So then comes the part that is hooks. So for hooks, we have just focus on the type safety and the lint and everything. Then comes the skills part. So the skills are quite different than the commands. So as commands tells Claude how to do it, skills teach Claude what to do. For example, a playwright skill includes locator strategy, the framework architecture, the playwright MCP architecture, testing strategies, TypeScript, and language specific conventions. So Claude already understands them via skills. So we have also focused on this only in our skills. Then we have used the certain folder structure for it, and we are using some requirement files. So login we have already seen. So now we will focus on the dashboard page. So we have a requirement file which is created by AI only. As Ali mentioned earlier, this will be more in a better in our next session. So what is the requirement file is basically it has some scenarios pre-written by the AI. So imagine that a product owner writes a Jira story. The BA defines the acceptance criteria, and manually people are generating the test scenarios. So instead of rewriting all this information into automation at one by one, we gather all the information into these requirement files, and everything generated afterward is solely depends on this requirement only. So this reduces the ambiguity and the keeps automation aligned with the current framework structure. Then we have certain folder structure defined of all the services, test data, test UI, and everything. So one of the common misconception is that the AI eliminates the need of a good framework. So at a, so it is quite contrary to it. Instead, AI, when a certain context is given to AI, it generally helps the AI to build certain code and certain project enough into a scalable level. So here we have followed the same approach. We have given a boilerplate at the start only, so it does not deviate from what is asked and what is not asked to do. So for our demo, we will use the Claude Sonnet from the Claude Code, and it has certain modes in it. So there are plan mode, accept rates mode, auto mode, and everything. So in this demo, we will use the plan mode and the auto mode. So what we have to do now, we have to just give our custom command that was scaffold, and the name of the command file that was dashboard about MD, and then the playwright agent will know what to do. So if we talk briefly about what is plan mode, so plan mode is useful whenever we want Claude to understand certain context of the problem before making any changes to it. So rather than editing the files immediately, it first analyzes the requirements, identifies impacted components, and proposes an implementation plan. So once the plan is approved by us, so there are certain options at the time of the plan implementation, whether the user can approve the plan at start only, it can accept edits on every path, or you can even change the plan to ask the AI to generate the plan in a better way, and etc. So this separation of concern with the environment of human intervention reduces the unnecessary code changes and provides a greater confidence before the automation begins. So as the scaffold command is now being executed by the Claude Code, it has started to explore the code base before even changing anything. So it will start with exploring some agents. As you can see on the screen, it has started the exploration agent to finish gathering the context before drafting the plan. So the plan mode is it takes around 4 to 5 minutes. So what we will do, we will fast forward it. We will just fast forward it, and we can see that Claude has written a plan for our implementation, and we can go through the plan that what is needed to be created and what is present already there. So we had login test already prepared for it. So login test will not be created here. It will just focus on the dashboard. So for our demo, we will use the auto mode. So the auto mode has been started, and it has some checkpoints in it, and it will start with generation of everything. So it will first check the whatever the business flows in the requirements file only using the Playwright MCP. So it will start the Playwright MCP agent now, and it will walk through the application as per the requirements. So in the prompts and in the as the guardrails, we have mentioned that always follow the requirements. It should not think of its own. The requirements file is only the source of truth for the Playwright MCP, and you can see on the screen that it is creating the flow for the about page on the dashboard. So it has clicked on the profile page to go to the dashboard page, and after that, after inquiring all the certain locators and everything, the flows, it will start to move to the next point basically. So we will see like what it does afterwards. So it does type checking and everything, right? So the test is now created by AI. It will just go through the test, all the MCP and everything, and it will create the test. It does create the page object and the test data also. So test data comes from the requirement files only. It does not create anything vague. It just follows the data that was written in the requirement file, and it just follows the same. So after the test data, the test is created, and it has automated all the scenarios that was mentioned in the requirement file and redirected to all the locators and everything. So it has used all the Playwright standard locators, the whatever is mentioned in the Playwright docs and everything, and it has used certain logger and everything for the better scalability and better instruction on the reports page. So after creating the test, it just continues to execute the new test. As you can see on the screen, that is a script is being run, that is npm run test UI. So the tests are being executed, and it will just start executing the test. And after the text execution is completed, it will give us small report to us, like what are the condition of the test, if the test are passing or failing, or if there is an issue. If there is an issue, it does add some comments to it, like the requirement file and the application are not behaving the same. So it flags to it rather than creating or updating the bug on its own. So we have made some change. We have made some assertions in the start only that never to update the test on the behavior of the application. It's just to follow the requirements every time. And you can see now that all the three new tests have passes. And what is it is being done that for the no checking of the no regression, what it does, since it has some login test presents also, and it has made some changes in the common file. So it will do, we have made it subjectively that run all the suit present, so that no flakiness or no regression occurs at the runtime. So what it will do now, it will just run whole suit, and execution has been done. So after the execution is being done, all the report is being generated at the last. So another common question, which is like whether the Claude uses more tokens and it takes longer than the traditional coding assistant as compared to the Copilot, Codex, and Playwright agents. So Claude processes a much richer context. The answer to is yes. It does take more time than the agents, but it is a deliberate trade-off. So it has some additional reasoning at the back end. So it requires some more tokens and slightly more information as comparison to the other models, but it is significantly reduces the duplicate work, inconsistent implementation, and rework during the later sprints. So in the summary way, it is quite useful for people to give some more tokens and have the good work. So we will see that the execution has been done, and let's see the report, like what has been executed by the UI. So it has generated all the report that all the dashboard and the pretty much login feature tests are passing. So this is pretty much from the Claude side.
Thank you, Rajat. I think I really like the way we have those instruction defined. You were sitting and then agent was doing all the work and you just to review it. I think that really these things looks like a magic, and But I think the way we have built these agents, it'll always make sure that the tests that are written are as per the standard that we have defined, like the locator strategy, the assertion, the loggers. I think once the tests are created, we really don't need to spend a lot of time reviewing things because the agent has already followed the instructions. Even the even let's assume if you're not using the custom agent, the Playwright MCP does really good job, but it has to, you have to provide prompts, you have to provide instruction to agent that what has to be done, what locators, because we have tried with both custom agent and Playwright MCP agent, and we had to do a lot of rework when we were reviewing those test scripts. I think it was a really good session, and I think I would like to have one question before we jump into the Q&A session part. What do you think? When you build these framework with custom agent with Copilot, with Claude Code, and more often, not using the standard method. Did you save a lot of time? Do you see that the token consumption was less when you use these custom agent, or was it more as compared to the standard played MCP agent?
So yes, Ali, actually that was a very much of interesting work. So first we had a plan to work with the standard agents first, and they had their own pros and cons. And after analyzing in very detail all the pros, we implemented our own custom commands and everything using our AI agents on our own. So we took all the pros in it, and whatever cons we had to see on the default agent, we tried to reduce it by giving the guardrails it and restricting it to follow whatever we are instructing it to do, not to follow everything on its own, not to lose the flow, not to generate any kind of code. Always follow the requirements file, always follow the scalability. Do not generate weak code, do not take any locator. So these are pretty much examples from what we observed and what we try to do in our custom way.
Thank you. I think thanks Abhishek and thank Rajat for the demonstration. I think we'll move to the Q&A session. If there are any questions, we can take up those questions right now, or we will have a few more sessions planned in next month where we'll showcase how we have built our own in-house tool for generating the test cases through requirements, through documentation, through Jira integration. I think that would be a really good session to join in next month, where we will showcase how we have used multiple different AI agents, like we have used Gemini over there, we have used OpenAI, we have used Copilot, we have used Claude Code, different agents, and we have explored that how those agents can help us write better test cases with a lot of understanding around different functionality of the application. So I think that'll be a really good session to join in next month, and we have few more sessions. We'll talk about how we use Codex, how we can use Cypress with AI agents. So there'll be a lot of sessions planned in months ahead, where we'll talk about how we are enhancing our capabilities with AI agents and models, and how we are using it for test automation quality purpose. So we'll wait for a few more questions. I think we are pretty much on time.
Yeah, so we have one question from Pallavi. So she missed the hill prompt related thing. So what needs to be implemented in the hill prompt? So basically, we should give the first of all the role that needs to be performed by the particular hill agent, and then the instructions that needs to be given. So first of all, we have two types here. The first of all is fixing the defect and reporting if there are any real bugs. So we need to give some of the scenarios, like if there are any fixable things. So if there are any locator drift, they can be fixed and how they can fix. So that's the one part. And after that, there is another part where like there is mismatch in the assertion. If suppose we want the output as a $45 and there is a $35, so it's gonna be report us back like it is a defect, so you can report that thing. So that kind of things we have implemented in the hill prompt. So it can be the application specific. First of all, it was the first generic one. So whenever we want to fine tune it further for the application, we can implement as a application specific. So that will work much better for the application specific things and heal part.
Abhishek, there's another question where Dennis want to know what was the approach of crafting these MD files for scaffoldings. Because with our experiment we have seen that the model can understand different formats of the file, but I think we found it the .md file with clear English like language is easy for model to understand. You can add up from your experience how it helped with these agent.
So the approach was first of all, there are different kind of things while writing the prompt. So for specific things, like we are demonstrating here the Claude and Copilot. So each one has their own requirement, how the prompt should be written. So first of all, we clear them with their role, their instructions, and the action needs to be performed. So like what to do and what not to do, we need to clear about that thing while doing the automation things. So that kind of things we have implemented in the scaffold and the heal prompt. So it has the context for properly where it want to do the particular task and whatever the required scenarios. With our experience, what we found, like there are these kind of things and steps needs to be followed while doing this such kind of automations. So that we have given in the scaffold prompt to identify those things and fix them accordingly or execute them accordingly.
There's one more question from Steven. He want to know, if the build fails, can we heal it or can we log it to the tech leads? That knows it. I think we have seen those implementation with MCP. We can integrate, MCP for Jira, or we can integrate MCP for Notion, where we can push the results from a test failure to the board or to the particular channel. Could be Teams channel, could be Slack channel, and I think we have done it in a project where we can see if the tests have failed and what are the root cause. And I think there are few more sessions that we'll plan where we'll showcase that how we can analyze those failures and give a very good insight from those analytics and integrate to the those MCP integration. I think there are sessions that we the implementation have done and we can showcase on some of the sessions in future.
So there is one question regarding the page object model. So are keyword based or like on other types of. So first of all, while writing the page objects, we have the form instructions.md. In that we have written prioritize the playwright based locators first. So that gives us advantage like get by text and other things that needs to be followed from there. And if there are anything that needs to be addressed, so we can use the CSS selector and XPath. That also can be found through the Playwright MCP by accessing the DOM. So this is the step-by-step procedure. So first prioritize the Playwright. If they are not present, then we are falling back to the CSS selector or the XPath.
I think we are on time. Thank you everyone for joining us today. I do see there are questions coming in. Definitely, we will have few more sessions where we'll talk about what are the best practices that we have followed for our customers and how it has helped. We'll talk about the utilities that we talk, where we are building the test cases through multiple models. We are building tools where we are analyzing the test runs, the reports, and giving insight. So a lot of new capabilities and new tools that we have implemented in house and for the customers and how they're helping them. We'll like to share those and we'll plan some more sessions in the future. To showcase how it has helped and how they are been implemented. Uh, Thank you everyone for the time today, and I think it was a great session. Feel free to connect with us and ask about how these things have been implemented, how they're helping, and definitely would like to share and talk about this implementation, how it has helped our customer, and for additional. Thank you everyone for your time, and I think we will keep you updated for future sessions plan that we are doing next month and ahead. Thank you, Abhishek. Thank you, Rajat, for your time today. And I think it was good demonstration that we had today.
Yeah.
Thank you, everyone.
Thank you. Thank you. Thank you, guys.